I think people just throw it out and forget about it, and they never realize the massive potential that's in garbage.
Garbage, sewage, toxic waste. Call it what you want, but you just can't ignore the amount we discard.
160 billion tons of waste in the next 10 years in the United States alone.
What if there was zero waste? What if every single thing we once had no use for was not simply tossed out, but put to work? You're about to follow waste from the landfill to the lab, where high-tech fibers make even sewage reusable.
The masterpiece of chemistry called membrane fiber.
Where toxic chemicals are replaced by the power of green tea.
And there's certainly nothing toxic about tea.
And where the power of plasma will blast our waste problem into oblivion, leading the way to zero waste.
Garbage in and of itself is not very popular. But when you take your garbage out on Thursday morning at 7 a.m., when you come home at night, you want it gone.
Every year, we produce enough plastic film to shrink-wrap Texas, dump 1.3 trillion gallons of raw sewage, throw away 50 million tons of paper, and enough glass bottles and jars to fill Chicago's Sears Tower over 60 times. And it has to go somewhere. Typically, it's the landfill. But one company has made it their business to commandeer that garbage before it hits the landfill and are using it to make something worthwhile, even marketable.
We looked at what people were throwing out and built a product where every part of it was what people were throwing out. Hi, my name is Tom Zaki. I'm with TerraCycle. We make products out of garbage. That idea that you could take garbage and convert it into something that's, very valuable is what drives everything we have. Waste is really just a commodity people are willing to pay to get rid of. So it's a really cool, source of material because it's someone else's problem.
Tom's first product, turning garbage into something every garden can use.
We fed organic waste to worms, and worms eat it and poop out worm poop, which is a fantastic fertilizer. We take that and we liquefy it in big tanks.
Come on out, guys. TerraCycle's little laborers. These are called red worms or manure worms, or the Latin name is Aceta fetida. They will eat any organic matter they've got around, and then they poop out these little membranes, little sacs of reduced organic matter.
So not only do the worms capture all the useful nutrients, they also generate beneficial bacteria, aka worm guts.
Within a few millimeters of entering the worm's body, the human pathogens will be gone. So then we end up with beneficial microorganisms.
What we focus on aggressively today is all sorts of organic waste.
Animal manures, waste from paper products, so that gives a carbon source to balance your composting process. They love bread. You throw worms in on bread, and man, it's just gone.
It's all part of an ingenious recipe.
What you're seeing right now is worm poop being liquefied. The worm poop starts by organic waste that's fed to worms that poop out worm poop. We then add the worm poop to water. We bubble it to get all the chlorine to be dissipated from the water. We then add oxygen, we stir it, we add heat, and we're brewing worm poop. And it's sort of like making tea, except it takes 5 days and just a little bit more science around it.
The liquid worm excrement is then put into storage tanks until it enters the bottling process.
Then the packaging was garbage as well. We actually went around to thousands of schools and recycling centers and sort out used soda bottles. So one would be a Pepsi bottle or a Coke bottle, and instead of melting it down and recycling it, we just actually reuse it, where we wash it out, take off the label, and then when you walk into a store, they're all different. We're actually the first company in the world to do that. So everything we use is a waste stream. Anything that we can get our hands on that is a pure stream, we're very excited about because we can make that into a product.
I'm Doreen Holly, and I'm the inventor of the fire lock. Ta-da!
Doreen is another one of TerraCycle's inventors, and not the first that might strike it rich on waste.
A little over 100 years ago, gasoline itself was a waste product or byproduct from making kerosene. And now, of course, you're going out and filling up your tank for $50 to $100 per fill up, and you see that this waste product actually became a very valuable commodity.
The log is made with biodiesel byproduct, glycerin. They can't flush it, they can't put it in a landfill. So we're actually taking it, it's a nice fit. We're taking it off their hands, putting it into a product that is reusable.
So TerraCycle is firing up, a whole new way to fire up.
We have wood chips, sawdust, along with the milk carton, shredded, and with the glycerin, we're going to heat it and mix it so it's a homogeneous mixture. And then after that, what we do is we take it and compress it into a log form.
So we wanted to create a fire log wrapped in the most obvious thing for a fire, used newspapers. And that is the product that you will see on probably every retailer next year, is this hyper eco-friendly fire log made and packaged out of garbage.
What do you think that we could look at in there that we can make another product out of?
If people can do more of like what we're doing here, reuse garbage, and to make it just another thing you use, you will create demand for it. From an economic perspective, I'm going to leave a very rich person, and I get to save the world in the process. And that's just, I can't ask for anything better than that.
While Tom and company keep intercepting garbage for their own use, most of it still makes it here, to the landfill.
My name is Steve Batchelor. I'm a garbage man.
Welcome to Settlers Hill, a 400-acre landfill, home to an estimated 19 million tons of waste.
Represents about 25 years of waste.
MSW, Municipal Solid Waste, so it is your kitchen garbage. Paper, a lot of organic material, food waste. Could be some bicycles in here, maybe an old couch.
But this isn't just a garbage dump. This landfill is designed to protect the environment and produce energy.
Landfills have a negative rap. People think that they're going to pollute the environment, when in fact they do the opposite. They're actually designed to protect the environment. When we construct a landfill, we excavate the soil and we get to stabilize soil. And then when we line it with so many feet of compacted clay, and then along that clay layer, we put a synthetic plastic layer on it that we basically seal, make a great big giant bowl.
Once the bowl is filled with garbage, it's sealed and covered with topsoil and is usually ready for retirement. But for Settlers Hill, it's time to go to work.
It's become a bioreactor. The waste mass has become anaerobic, and it's producing methane gas.
As anaerobic microbes process garbage, they give off methane gas that is piped out of the landfill. All landfills eventually produce methane, which is 21 times more potent than CO2 as a greenhouse gas. The most common way to deal with this atmospheric challenge is to burn the methane before it enters the atmosphere, thus ignoring a powerful resource.
Waste Management saw that we had a problem with wasting good energy. So what they did is experimented building a plant where we could burn the gas as fuel and produce electrical power.
Scientific irony, the world's most promising source of clean energy might end up coming from its dirtiest places.
This goes down into the waste mass, into the landfill where the gas is being produced. There's probably, say, 25 miles of piping connecting all these wells and conveying all that gas to the plant. That's sucking air in and comes back in.
The main thing is we cannot let landfill gas, which is greenhouse gas, get into the atmosphere. So no matter what, that's the first challenge. My name is Patrick Mundinger. I'm the Plant Operations Manager here at Settlers Hill Renewable Energy.
Pat keeps this unique landfill operating as a power plant.
These are two Centaur turbine engines. They burn the landfill gas and produce electric power. It's a jet engine. Same thing you find on the airplane when you're going down to Las Vegas or somewhere. And once we get the gas, now you have moisture in the gas. You have to get rid of the moisture. It's very, very wet. You can't just burn it. Then we have to compress the gas. Then it goes into the turbines.
And from the turbines to the power grid.
From that, we provide the city of Geneva, Illinois with about 10% of their electrical power.
And that's only the beginning. According to the EPA, there are 445 landfill waste-to-energy projects going on right now that power over 1 million homes.
There's about 500 candidate landfills that generate enough methane gas that could be also used for landfill-to-gas-to-energy projects.
And that's not all. The land above the landfill has been donated back to the city and turned into a golf course with an energy-producing punch. Landfills can power the grid, but there's plenty of power-producing waste that never makes it to the landfill. Cow manure. It's powerful stuff. Welcome to Ludhiana, India, where the manure from these cows is powering a city. Cattle dung is collected from local dairies.
They are collecting their cattle in small carts.
They deposit their loads into collection tanks. These tanks are part of the biomethanation plant, the main source of power for this growing community. The Habawal Dairy Complex that supplies the plant has 500 dairies with 150,000 head of cattle. It produces 2,500 tons of manure each day. We may simply call it manure, but they call it a locally abundant, self-replenishing energy source.
Biomethanation is a process by virtue of which we can degrade the organic matters, like cattle dung here.
The dung collected is blended in collection tanks and sterilized. Then the mixture is fed to the digester.
And in digesters, there are already millions and billions of bacteria that are decomposing it to the final products.
This biogas consists of carbon dioxide, methane, and hydrogen sulfide. Like Settlers Hill, the Habawal complex is harnessing the methane. The electricity is formed as the biogas is burned in a 1 megawatt capacity engine.
You see, such kind of plants are producing 16,000 units per day.
Each methane engine can power over 300 homes. And with the large cow population around the globe, you can just imagine how much their daily contributions could help light the world. Before you toss out that next piece of garbage, consider this. That styrofoam cup could be your next polyester suit, your soda bottle, new carpet in your living room, milk jugs, playgrounds.
Scientists all over the world are working on ways to reuse almost everything that we now, and for the last hundreds of years really, have routinely thrown away.
But right now, we're only skimming the surface.
9 out of 10 tons of plastics discarded in the United States are not recycled. This is uneconomical, and it is an ecological mistake.
Which brings us to a most familiar question. Paper or plastic?
My name is Tom Nosker, and I'm a plastic man.
Dr. Nosker is the principal investigator of the Plastics Center at Rutgers University. Tom and his team of graduate students have developed a way to turn your old milk jugs and plastic hangers into building materials stronger than structural steel.
I went to my PhD advisor and I told him that I was thinking about mixing different kinds of plastics that were immiscible together. And he said, oh, they're just going to fall apart.
His first hurdle? Finding a way to mix plastics that don't mix, called immiscible polymers.
That's sort of what we're most well known for pioneering.
Ever notice those numbers in the chasing arrows on the bottom of your water bottle? Each number stands for a different kind of plastic polymer.
Number 1 is polyethylene terephthalate, clear water bottles. Number 2 is high-density polyethylene. Number 3, number 4 is low-density polyethylene. Number 5 is polypropylene. And then number 7 is mixed resins.
But having a number doesn't mean it's easily recycled.
Most household recycling systems in the United States collect bottles number 1 and number 2. What I have mostly focused on has been trying to figure out what to do with some of the plastic that has had limited value.
But there's still the issue of compatibility.
I thought that there was something wrong with thinking that you had to have chemical compatibility in order to get these things to bond well together and to make something useful.
What Tom's done is find a way to build a normal-looking bridge with a not-so-normal molecular structure. And this bridge is revolutionary because it's proving that 2 polymers are better than 1.
Here's a bottle that's made from polyethylene. I can crush it. I can change the shape. It doesn't fracture, so it's strong, but it was easy to crush, so it's not stiff, and that's a problem. So you wouldn't want to make a bridge out of polyethylene because it would sag. Conversely, if we had polystyrene, it's very stiff. The problem that it's got is that it's brittle. It might fracture under the wrong circumstances.
That's when the light bulb went on.
And it turns out that if we blend those 2 polymers together, we can make something that's got in-between properties.
The trick is how you get the different polymers to bond.
We make our blends of immiscible polymers by melt blending them. We've got special techniques that we used in order to get a very fine structure.
Tom's patented technique involves a machine that melts and mixes plastics, called an extruder.
This extruder here is a special single-screw compounding extruder that's going to revolutionize a number of plastic processes.
This single-screw design can mix plastics to the micro scale, so the polymers can bond mechanically.
If we mix it properly, we can get an interlocking three-dimensional structure. We get mechanical bonding.
In a mechanical bond, materials maintain their molecular structure and become linked to each other by forming interlocking shapes.
We vary the percentage of polymers in the mixture. One of them is going to be a preferential shrinking material, so we'll want to crystallize and shrink and squeeze the other material.
The combination of the two is what makes Tom's plastic lumber strong enough to hold a 10-ton truck.
It can withstand a very high load for the amount of weight of material that it is. The fact that the plastic lumber may outlast a wooden item by maybe 10 times makes it a huge advantage to use recycled plastic as opposed to wood. Only God can make a tree, but we can make plastic lumber as long as we want.
But before plastic can be recycled into anything else, it has to get collected, sorted, sifted, washed, and transported. A lot of energy spent for a plastic bottle. So what amazing machine could sort through this stuff automatically? Meet MRF.
MRF is an acronym for a Material Recovery Facility.
This mammoth invention can tackle all 154 tons of recyclable materials it receives every day. It might look like garbage, but this MRF is cutting edge. It's equipped with technology that enables MRF to separate materials from a single stream.
Single stream recycling is really a situation where we've taken sorting your recycled material in a controlled environment, such as a recycling facility that's able to sort it automatically.
So recycle your old multicolored bins, because being green has gotten even easier.
It gets dumped in one large pile on what we call the tipping floor. From there, the tipping floor goes on to conveyors to various screens. So it first goes to a cardboard screen, and then from that it goes to another section where the newspaper is removed, and then the remaining material is the containers. Aluminum cans, the tin cans, plastic bottles, glass bottles are gone through another sorting process where the glass is separated, the tin is separated by magnets, and then the aluminum is separated by an eddy current, which is, an eddy current actually causes the aluminum cans to jump off the conveyor belt.
An eddy current uses magnetic fields to separate the materials.
We use centrifugal force, we use magnets, we use gravity, all these things that help us in the process of recycling the material and separating the material to make it a commodity that's acceptable to those businesses that need it to make their products.
Once the material is completely separated, it's packed into dense bales ready to recycle.
We recycle about 5.5 million tons of recycled material every year. Within that 5.5 million tons, we recycle enough paper to save 41 million trees.
Clean, drinkable water is going to be as valuable in the future as oil is today.
For instance, the United States uses 450 billion gallons of water every day, and we flush 40% of it down the toilet.
It makes no sense at all to be using drinking water in our toilets.
To use less water, perhaps we just stop flushing. At the Eco Restroom Project at the Bronx Zoo in New York, they're doing just that. But what do they do with what they don't flush?
I'm John Dolan, and I'm changing the way people are thinking about poop. The world is ready for composting toilets. People love them. This is a very, very popular facility.
What makes it so popular is the latest and greatest in green technology.
Don't show them that. It's going in the women's room, okay.
A flushless composting toilet that keeps water use to a minimum and puts what we flush to use.
This sheen of foam that goes down the bowl. Wow. Use paper, it's all good. Toss it down. Press the button again.
This foam is made from a small amount of biodegradable soap, and the best part?
There's so little water in this foam that this fixture uses less than 10%
of the most efficient typical fixture.
It doesn't flush.
Instead, it just slides down the pipe.
And below us, the bugs are going to eat your waste.
The out-of-the-box thinking continues under the toilets. This is Don Mills. He works with human poop.
I think it's proper to refer to this material as nutrients.
No, it is. It's human manure.
That's right. These nutrients can actually work for you.
What's happening in this device is that we are using gravity to separate urine from feces. The organisms do their work of decomposition.
These red worms have the unique ability to remove any human pathogens, and after about a year, the product is ready to use.
We'll shovel it out into wheelbarrows, and we can raise the material up to the street level where we can ideally use it as a soil amendment.
Does he really expect us to use human excrement to grow food?
We are putting into this only what's going into us.
In that case, why not just use sewage for fertilizer and cut out the extra step?
There's nothing wrong with human waste. What is a problem is when human waste gets mixed in with storm systems that are flushing out oils, drains that chemicals and other items are poured into. That's where, at the end, we have a toxic situation. Composting systems are one way, and a great way, of addressing our sewage problem.
Even if we use John and Don's toilets and cut down on the flushing, our sewer and drain systems are filled with all kinds of wastewater, polluting our most precious liquid.
The #1 cause of death on the planet is due to waterborne diseases. 5,000 children a day die from waterborne diseases.
So abundant clean water is a must. Conventional wastewater treatment requires large facilities, multiple stages, and can't keep up with the increasing amount of water we make dirty. But that's because they didn't have ZWeed, until now. ZWeed uses cutting-edge membrane technology to clean wastewater faster, in 1/4 of the space, and better than anything else around.
As the world becomes increasingly water scarce, we're going to see water reuse as a major trend of the future. And ZWeed is a great technology to enable that.
With ZWeed, what is flushed can eventually be reintroduced to the water system and reused. And drain water can actually be used as drinking water.
We call it ZWeed because it's very similar to seaweed. And seaweed does a couple things. It moves naturally in the ocean, and this ZWeed moves very naturally in application underwater. At the same time, it acts as a cleansing feature of the water. And that's is a parallel to nature. If you can imitate nature, it seems to be the best solution in terms of your technology. So it's a combination of high technology and imitating nature. Hello, my name is Gerald Harrison. I'm the plant manager for GE Water and Process Technologies.
Each membrane cassette is made up of 125,000 strands that are bundled up and suspended directly into the water that needs to be cleaned.
Through vacuum pressure, the water moves through the pores into the bore and is sucked up through, similar to a straw.
Every strand of ZWeed contains billions of microfine holes, nanopores, that allow water to be sucked in and keep particulates out. This remarkable filtration technology requires some remarkable manufacturing technology. The process starts with a polymer called PVDF.
Take the PVDF, which is a polymer, it comes in pellets. And what we do is the pellets go into the solvent and it dissolves at a certain temperature. And then we add in some other inorganic materials, organic materials, and that's what formulates the recipe. And we end up with a material called dope, which is a thing that we use to form our fibers. This is what it looks like. It's like a molasses or honey. It's very, very, very thick. And this is the starting point of making the membrane.
The next step is to degas it.
We have to get the air out, because if you don't, then it causes issues with the fiber integrity, causes very large holes in the fiber, which of course makes the fiber not usable.
Which would mean the pathogens could get through. Once the gas is pulled out of the dope, the fibers will be shaped and molded with a bore fluid that fills each to create the tube structure.
A liquid within a liquid, essentially.
Then something amazing happens. The actual pores are created as the chemicals in the bore fluid bore through the dope, leaving a porous structure behind.
It's not so much what's in the fiber as what comes out of the fiber, which forms a pore structure. The pore structure on here is from 0.02 microns to 0.1 microns in diameter.
The holes in the membrane are 4 times smaller than an HIV virus. 60 times smaller than E. coli bacteria, and about twice as thick as a cell membrane in the human body. So it filters just about everything, leaving amazingly clean water.
So we block out bacteria, and we block out some viruses. We're up to 6 log removal. 6 log would be 99.9999, or maybe more. Currently, we're manufacturing 15,000 square feet of membrane a day, which translates into probably 15 million square feet annually. And this has the ability to treat about 1.5 million gallons per day of water. The overriding goal is to provide clean drinking water and reusable water for the world.
Although some countries have come up with ways to treat sewage and turn it into drinking water, that's not allowed in the U.S., where wastewater is treated and returned to rivers. But with seaweed, that just might be possible.
Countries such as Singapore that are really out in front of the curve. They're actually taking wastewater and recycling it to drinking water.
Perhaps more than anything, the only thing missing for us is not a technology, but a mindset that we could successfully transform our own sewage to our life source. Accelerating technology has produced its own kind of waste. Almost 1 billion obsolete electronic devices are tossed out every year. Cell phones, computers, televisions, and monitors, all contributing to an epidemic some are calling e-waste.
You know, across the world, landfills are being filled with electronic waste.
Most of the toxic heavy metals found in landfills comes from discarded electronics. Our computers also leave behind more than 6 billion pounds of plastic, 1.5 billion pounds of lead, and some 600,000 pounds of mercury.
There are several toxins that are found in electronics: lead, mercury, bromated flame retardants, chromium, beryllium.
Nasty poisons that cause behavioral deficits in children, brain neuron degeneration, cognitive dysfunction, cancer, and pulmonary lesions, to name just a few. And what do we do with it? Most of it we simply ship to landfills overseas, causing havoc to the health of the world.
E-waste is the fastest growing component of the municipal solid waste stream. We need to come up with ways to manage e-waste in the same way that we need to come up with ways to manage all wastes.
Manage e-waste? Done.
Better is all recyclable. Okay, this is not trash, and that's why I call it e-scrap and not e-waste. Because e-scrap to me has value. Waste to me, I believe the definition, if I may, is something that is non-recyclable. I'm Jim Glavin, and I process electronic scrap. Currently, this facility processes on average about 4 million pounds of electronics per month. These are cathode ray tubes, what are commonly known as CRTs. These are actually the picture tube that you look at when you're watching either your television or your monitor if it's a CRT-based piece of equipment. They actually contain lead and have to be processed and handled in a very specific manner. We're literally dealing with thousands of different electronics. If you think of all the things in the world that have a circuit board on them, we process most of those here. From this facility, there are no electronics that go to landfill. Everything is recovered.
With the help of one hardcore machine called the shredder.
Now here, this is where the shredder is now reducing these monitors to approximately 3-inch pieces. And basically, the reason why we need to shred those is so we can create liberation.
Similar to the MRF, like materials are separated from the parts they're attached to.
Manually remove the copper bearing streams, or we're using magnets to remove the steel, where we're using pulverizers and trommel screens that are act as sizing devices to screen out the leaded cullet in the glass.
But the shredder can't handle everything. Some materials still require a little TLC.
We can't just throw this into our shredding system, shred all this stuff up, because we still want to recover a lot of the value. And a lot of times recovering the value is sorting the equipment to maximize its value. Then from there, we would then take it to reclaim the precious metal at our refinery. Okay, and then we would recover the gold, the silver, platinum, palladium, copper, and other elements.
Thanks to Jim and Company, no waste goes to a landfill, not even the packing materials.
We are working very hard to create a world with zero waste, recycling everything that we can.
Jim is using technology to combat our addiction to technology. But making these electronics also produces toxic waste. Manufacturing your computer requires hazardous chemicals, which end up in the water system, and the landfill, and the ecosystem. One Tucson-based scientist is brewing up a solution.
Hi, I'm John Lombardi, and I'm a big proponent and believer in tea.
Green tea doesn't just combat free radicals. It can also replace an antifreeze-like chemical currently being used to manufacture computer hard drives.
Because antifreeze is toxic.
But the organic solution made from green tea can accomplish the same positive results.
This is a solution of essentially polyphenol-type derivatives, which are used in hard drive polishing. Not too far off from some of the ingredients that you might find in a cup of green tea, though I'm not going to drink it.
John's brand of green chemistry is called clean production.
Clean production is a global trend. It's a way of producing goods and services that minimizes water pollution, waste generation, and habitat disruption.
We're not looking at replacing, material components in a hard drive. What we're really looking at is ways of manufacturing those parts more efficiently, as well as producing less waste during those manufacturing operations.
One of those parts is the read-write head from your computer's hard drive.
Pretty thin wafer-sized type material.
This little piece of aluminum oxide and titanium carbide is a precision machine that must withstand disks rotating at speeds up to 15,000 RPMs.
As a result, you need really smooth surfaces.
With this machine, we're going to polish a read-write head. This is the galleyed solution.
Tea is a really amazing series of complex mixture of chemical compounds, specifically the presence of compounds called polyphenols.
Ever notice that ring around your teacup? It's the polyphenols.
That's one of the reasons why mussels and barnacles adhere extremely well to ship hulls.
Its natural adhesion aids in the polishing process.
The idea is to make an additive that you can put into the water. The big advantage of using water is you don't have the toxic handling issues. You don't generate the prodigious amounts of waste. And there's certainly nothing toxic about tea.
Another set of toxic chemicals we use every day is bleach and chlorine. And John has a replacement for that too.
Sunshine! So what we have is essentially a molecule called a phthalocyanine. We've come up with a series of compounds that absorb solar radiation. You have sunlight, and what will happen is there's an energy transfer where an oxygen molecule, when it's triplet or ground state, interacts with the excited phthalocyanine, and it converts it to what's called a singlet state oxygen, which is very effective at oxidizing and destroying different types of pathogens, bacteria, and things like that.
Which means cleaner water, fewer infections in hospitals, and even whiter sheets without using chemicals like bleach and chlorine.
Mother Nature has a lot of experience doing chemistry. Unlike us, she tries a lot of experiments. Some folks say it's evolution.
Replacing solvents with tea and sunshine is definitely green chemistry, avoiding certain toxic waste entirely. But what do we do with the toxic waste we already have? Especially the most toxic waste of all.
Let's talk about the current problem. We've got over 50,000 metric tons of spent nuclear fuel stored on over 100 sites across the United States.
Nuclear power may produce no greenhouse gases, but it does leave a terrible problem behind. Barrels like these are filled with spent fuel from reactors that will remain radioactive for the next 10,000 years. And it's piling up.
So going back all the way to the 1950s, there was some seminal studies, one by the National Academy of Science in the US, that's looked at various options for dealing with this radioactive waste. Shooting it into space, deep sea burial, burial in glaciers, and burial in various kinds of geologic settings.
The current plan? Bury it in Yucca Mountain, a radioactive waste depository currently being constructed in Nevada that won't be ready until 2017, and, at the rate we're going, will be filled before it even opens. A problem that one little government lab has been working on since nuclear science was invented. But this is today's Argonne National Laboratory, where, among other peaceful nuclear applications, world-class scientists are working to solve the world's worst waste problem.
My name is Monica Vergobito, and today with my team from Argonne, we are doing the impossible. We are recycling nuclear waste.
Monica and her team of scientists are developing nuclear waste recycling technology. If successful, it could reduce the radioactive waste generated by nuclear power plants by 90%.
What goes into a nuclear power plant is a fuel rod that has uranium oxide inside of a stainless steel tube. That goes into a reactor. The uranium actually fissions or breaks apart, produces energy, heat, which actually drives a turbine and makes electricity.
But once only 5% of the uranium has reacted, the entire fuel rod becomes too contaminated with other elements generated in the process and must be disposed of.
It becomes what we term spent nuclear fuel. It's no longer efficient at making electricity, so it's then treated as waste.
This very valuable uranium oxide is now contaminated with plutonium, americium, curium, and the fission products,
Pretty much the rest of the periodic table.
leaving a dangerous radioactive cocktail. Monica and her team are working to extract the usable elements for energy production.
So we have extraction, we have the scrub, we have a strip, and we have a wash. The goal of these technologies is to efficiently close the nuclear fuel cycle.
Simple, in theory.
The processes are what we call solvent extraction processes. For example, Italian dressing, where you have oil and water mixed together, you shake them, for example, and then the phases will separate.
Instead of oil and water, this process uses spent fuel rods and acid. Behind this completely airtight, lead-shielded glass is a very complex set of chemical experiments using specially designed machines called mixer settlers. These devices are designed with multiple stages of mixing and separating to extract the elements from the radioactive soup. The process is then sped up with a device Argonne invented called the centrifugal contactor.
So we can do the mixing and the separation of the two phases in 1 to 3 seconds. We're very proud that in the last 6 years, we have developed what we call advanced recycling technologies.
Except that here, you have to use robots and glove boxes to do it. This is a dangerous recycle.
Solving nuclear waste problems is not something easy or trivial or something that you have people volunteer to do.
But it's of tantamount importance, which is why Monica and her team do volunteer to do it.
We can't leave this in temporary storage, waiting future generations to bring solutions to bear. I do not want my grandchildren to have to face the problem of dealing with this radioactive waste in the future.
Hoping to dig us out from the millions of tons of garbage Americans produce each year, scientists have come up with amazing ways to reduce and reuse waste. But for a few scientists, the goal is even loftier, to zap garbage into nothingness.
My name is Andreas Tsangaris. I'm the chief scientist of Plasco Energy Group. The project that Plasco Energy is handling is to take 75 tons per day of municipal waste and convert them to electricity without producing any pollution.
This is Plasco, and their prototype facility is the first ever full-scale plasma gasification plant of its kind.
Our main objective originally was to destroy the waste.
But total destruction wasn't enough to satisfy Plasco. By using the technological equivalent of the power of lightning, their goal is to turn our waste problem into a profitable solution.
We do not regard ourselves as a waste disposal company. That's way too narrow a designation for us. Plasco is an energy company.
Waste to energy, a familiar goal, but the technological process is what makes it unique.
Okay, we're going to start firing the burners higher or harder, so you'll see some increased airflow.
The process that converts this waste into electricity is called plasma gasification. Plasma is sometimes called the fourth state of matter.
The first state is a solid. Add heat to a solid and it becomes a liquid. Add heat to a liquid, it's converted into a gas. Add heat to a gas, it's converted to plasma.
The sun is the best example of a plasma. Lightning is another.
They harness this lightning-like power by creating an electric arc between two electrodes. A small amount of gas is passed through those electrodes. The gas then ionizes and is transformed into plasma.
The gas can reach temperatures of 5 to 10,000 Celsius.
That's 4,000 degrees hotter than the outer layer of the sun. But even though it's exposed to intense heat, the waste is not incinerated.
Plasma gasification works in the absence or near absence of oxygen. Therefore, it's a process of decomposition and not of combustion.
The superheated plasma has the unique power to obliterate any waste in its path, completely decomposing it into its elements. It can process any kind of waste, biodegradable or not. Dirty diapers, concrete, sludge, even hazardous biomedical waste, and transform it into useful and marketable elements. In order to be reacquainted with its elemental self, waste has to go on a unique plasmatic journey.
The municipal waste travels up the blue screw conveyor and drops into the main chamber of the converter. There, the solid municipal waste is converted into what we would call a crude or raw synthetic gas that then travels up into the refining chamber, where we use the plasma torches to convert it into the product quality gas, which is rich in carbon monoxide and hydrogen. My name is Alistair McLean. I'm the Director of Programs at Plasco Energy Group.
What makes this approach revolutionary is how they organize the molecules into useful compounds after gasification occurs, the most important of which produces power.
The cooled and clean syngas travels through the yellow pipe to the 5 engines we see here. Each of these engines will produce just under a megawatt of power. Our sophisticated control system produces more power per ton of waste than any other waste conversion technology we know of.
Once the process gets going, it powers itself. And in the future, this technology will be able to turn garbage into any fuel gas, even hydrogen to power your future car. Same basic ingredients with endless potential. Almost nothing goes to waste, even the solids.
Here we use the plasma torch again to melt or vitrify any of the ash into a glass-like slag.
This silicate slag can be sold on the open market and used for everything from roadbed aggregate, building materials, even jewelry. In a city like New York that spends $90 a ton to handle its garbage, the power and slag that is created by gasification could let the city actually earn $15 a ton.
We're going to have about 1.3 kilograms per ton of waste of heavy metal and activated carbon. The only waste from this entire process.
That's just over 0.2% away from zero waste.
We are able to treat municipal solid waste in a much environmentally friendlier way than incineration can, or that landfilling does, or that adjacent technologies do.
But the technology is still being tested and approved, so it might still be a few years before plasma is powering your neighborhood.
We're building new technology, and beyond that, the whole industry. We've taken this from a dream to a reality.
One step closer to a world with zero waste, but there's still a ways to go.
Most waste generated on the planet is not being managed in an ecologically desirable way.
As we've adopted new technologies, we've created new waste streams. That's a habit about to change.
You have to dream the impossible to achieve what's possible.
A new generation of scientists and engineers are developing technologies that will eliminate our existing stockpiles of garbage while leaving nothing new behind.
Zero waste is an admirable goal.
Zero waste. Now that is ecotech.